Hello everyone. In this video, we'll be discussing about inheritance. So we learned that inheritance is the property by which one class can inherit or gain the data members and member functions of another class. So why do we do that? It is to promote reusability of code. For example, here I have a class called base in which there is a constructor and there is a function which we have defined. Then there is another class called derived in which there is another constructor and one function defined. Now what if we want whatever functions are defined in this base class? For some reason we want all the functions to be used. We want to use the same function, the exact same function in a derived class as well. So one way we could get around this is to copy paste all the code we have. But what if we have 1,000 functions in this class? You can't copy paste the same thing over here because that would increase the length of your program. So the way you get around that is simply using inheritance. What we do is in a similar fashion, we during the class definition here we specify after the colon what all classes do we want to inherit from. So in this case, my derived class inherits from the base class. Now what this allows us to do, or rather what it does is it brings all of the implementation of the various data members or the various member functions onto my derived class, meaning that derived class can now actually access the function called base function. If we had another function called void bf2, then it will be able to access that. If there is any other data member called int a is equal to 10, then it will be able to access that as well. So that is why we use inheritance, so that we are able to reuse the code which has already been implemented without having to go and write it again ourselves. So now let's see this in action. So what I'm doing here now is I created an object derived of the derived class called d, and I'm calling the base function, which is the function present in the base class called base function. And then I'm also calling the function which I defined within these class braces itself called function in derived. Let's see what we get. So forget this part for now and just focus on this. So we get hello from the base and hello from the derived, which is what these functions do. So in this way, simply by using inheritance, we are able to use an entire functionality which we had already implemented in a new class. So now let's discuss a little bit about access specifiers or access modifiers. So we had discussed that access modifiers such as uh, public, protected, or private, they help to define the scope to which the variable or the member method which has been defined can be accessed. For example, a public is accessible anywhere, a private is accessible only within the definition of the class, and a protected is accessible both inside the class and in the subclass. Now you can see here that when I am actually you know deriving a base or inheriting another class, I am specifying an access modifier. This is known as the mode of inheritance. So this, along with what was initially defined in the base class for a particular member function or a data member, for example int a or char ch. So the the access specifier which is defined in the base class and the mode in which we are inheriting the base class both determine what will be the final access specifier or final scope of those data members and member functions in my derived class. So now let's first take a look at that. Right. So I have two different uh, photos or images through which we'll go through, and whichever one you feel helps you to understand better, follow that along. So now initially, when the component is declared as so and so, and when it is inherited as so and so, this will be the following result. So when we are inheriting as a public base, which is during inheritance, the mode of inheritance is public, then let's see what happens. If our component declared was public, it remains public. If our component declared was protected, it remains protected, and private is never inherited, so there is no resultant access inside the inside the subclass. Now if my mode of inheritance was protected, public would then become protected, protected would remain protected, and private is again not inherited. Now, if my mode of inheritance was private, public and protected both become private, and private again is not inherited. You can see the same in this photograph as well, that if in the base class we have a if in the base class we have a private data member or a member function, then it is not inherited regardless of the mode in which we are inheriting it. If in the base class it is protected, if we are inheriting it in the public mode, it remains protected. If we are inheriting in the private mode, it becomes private. And if we are inheriting in the protected mode, it remains protected. If in the base class we had defined it as public, if we derive it or inherit it in the public mode, it remains public. If we inherit it in the private mode, it becomes private. And if we inherit it in the protected mode, it becomes protected. So this has been all about mode of inheritance. Now let's go back to the code and learn a little bit more about the implementation, or rather some nitty-gritties about inheritance. So one of the things that does take place in inheritance, which you would like to notice, is the constructors. So remember when I had told you that leave this for now. So let's actually dive in deep and understand what's happening here. So I have my base class, I have my derived class, which is inheriting the base class in the public mode of inheritance. Here I have a default constructor in which I'm simply printing out base onto my console. Here I have a derived constructor, the default constructor of the derived class, and this too is just printing out derived onto the console. When I simply created an object of the derived class, let's see what happens. We see that base and derived are both printed, but how does that make sense? Because I've only created an object of the derived class. Shouldn't only the default constructor of the derived class be called? No, this is because implicitly whenever the default constructor is called, the default constructor of the base class is also called. And also, if at all I have a derived And also, if at all I have a derived class parameterized constructor, for example, int a, then what this will do is it will call a parameterized constructor of the base class, passing on the same argument a. If I have int a, int b, char ch, then even for the base, they will be called in the same order in a, b, and ch. So keep that in mind. Again, whenever the default constructor of the derived class is called, it implicitly calls the the default constructor of the base class. If we are calling the parameterized constructor of our subclass or the derived class, then along with the same arguments which is passed, the parameterized constructor of the base class will be called. So this has been all about some introduction to inheritance. We also learned about the mode of inheritance, and also how the constructors are actually called whenever we are creating objects in inheritance. Thank you.